you very much for the invitation that also gave me the opportunity of joining. The title, as you see, is... I'm Cristina Puzzarini from the University of Bologna, and I've just given a plenary talk. The talk was hunting for interstellar molecules. This means searching for molecule in the interstellar medium. But let's start from the definition of interstellar medium. So interstellar medium is the matter between a star system in a galaxy. And from Earth, if we look at the sky, this seems to be empty. Actually, it's not. Here we have rarefied gas and also some dust grain, a really small one, because their size is something like 1 micrometer in diameter. And also in the interstellar medium, we have a really harsh condition, a density so low that it's considered something like high vacuum on Earth. And also the temperature is extremely low. And this is the reason why until middle of the last century, the astronomer thought that there were no molecule in space. And everything changed in the last 50, 60 years. And nowadays we have more than 300 molecules discovered in the interstellar medium and circumstellar shells. And also these are not only small molecules formed by 2 atoms, but they are really even a large one with a complexity. And what is really amazing is that some of these molecules can be considered the building blocks of the biological molecules. And indeed, one of the reasons why we are so interested in understanding how many molecules and what type of molecule we have in the interstellar medium is because there might be a strong relation between the molecular complexity in space and the origin of life on our planet. And what I do as a research is try to figure out new exotic molecules that can be present in the interstellar medium. And with exotic molecules, I mean molecules that on Earth would have been really, really unstable, like ions, radicals, but also molecules that are simply very reactive in the terrestrial condition. But because, as I mentioned before, the density is so low and the temperature is so low, this strange molecule survive long. And what we do is, in my lab, in addition to think about new molecules that also might play a role in the origin of life issue, we wanted to characterize them from a theoretical and experimental point of view. The final aim is to have a sort of long list of this, what are called the rotational transition. These are well, this is something complicated. We are in the quantum chemistry field, so when we have molecule, the energy cannot vary continuously, but we have discrete level. And when a molecule rotates, it might be unbelievable, but the energy level related to the rotational motion of a molecule are quantized, so are discrete. And when we pass from a level to another, we observe what is called a rotational transition. And this is what happens in space. So the molecule rotate even if the temperature is so low, and they can pass actually from a level higher in energy to a lower level. And with this big radio telescope, we collect this radiation. And if we collect enough radiation corresponding to different transition, then we can be sure that the molecule is there. But of course, we need to know where, so at what frequency this rotational transition lie. And this is what we do in the lab. We figure out a way to produce the molecule. Sometimes we need to use DC discharge, which means our cell is a long glass tube. We have 2 electrodes. We apply high voltage, and so we start a reaction to produce our molecule. In other cases, we use what is called flash vacuum pyrolysis. So we put a precursor, another molecule, usually a bigger one, in this oven. It's really an oven that can reach a really, really high temperature, up to 1,200 Celsius degree. And then the heating of this precursor leads to the molecule we want to investigate. But we need to be fast because these molecules are unstable. And so once produced, they should be immediately observed using our spectrometer. So they are directly produced inside the cell or in a near reactor, in a near oven, and immediately sent inside the cell. And then we characterize all the aspects of the rotation of this molecule, which means that we characterize in any aspect of the rotational spectrum of the molecule. At the end, this work allowed us to obtain this long list of transition frequency, and this is what the astronomer search in space with the radio astronomer. And once we have a match between what we observe in the lab and what is present in the interstellar medium, then we can claim that the molecule is there. And this is really fascinating because building block of biomolecule have been detected there. And for instance, even a phospholipid head. So it really seems that the pieces of the biological molecules that are present in our body and in everything on Earth might have been delivered to Earth long ago. Nowadays, we have something like more than 300 molecules detected, and we are only at the very beginning. So let's thank you.